Take a question from linear algebra. The question says that let I be identity matrix of order 7 and A be a 7 by 7 real matrix having characteristic polynomial. So eigenvalues can be calculated from here by putting the polynomial equal to 0. So it is given that the characteristic polynomial for the matrix A is lambda square times lambda minus 1 power alpha times lambda plus 2 power beta, where alpha and beta are real positive integers. If A is diagonalizable matrix and rank of A is rank of A plus 2i, then what will be the rank of A minus I? Okay, so this is a fill in the blank question and there is no option given. It's a engineering mathematics gate question. So clearly few things are given here. Okay, so we are working with a 7 by 7 matrix. Okay, so A is a 7 by 7 matrix. So clearly you will have 7 eigenvalues for lambda for this matrix A, and eigenvalues will be obtained from here by putting it equal to 0. So clearly lambda is equal to 0 you will get from here, lambda is equal to 1 you will get from here, and lambda is equal to minus 2 you will get. So there are 3 eigenvalues, but they will be repeating eigenvalues because total 7 eigenvalues will be there. So clearly you can see that lambda equal to 0 is repeating 2 times. Okay, so each eigenvalue has some algebraic multiplicity. So if I write the algebraic multiplicity of each of these eigenvalues, then clearly this has the algebraic multiplicity of 2. This has the algebraic multiplicity of given alpha, that it is repeating alpha times, okay, where alpha is unknown, and minus 2 is repeating beta times. Okay, but what we know from here is that the total number of eigenvalues are going to be 7. So we know that alpha plus beta plus 2 is going to be 7. So alpha plus beta is going to be number 5. Okay, so this is known. Okay, that the eigenvalue 1 and minus 2 will be repeating such that the uh, sum of this will be 5. Okay, so that we have total of 7 eigenvalues for the matrix A. Now it is given that A is a diagonalizable matrix. Okay. So when a matrix is diagonalizable, this condition is important here because we are going to deal with rank, and if a matrix is diagonalizable then the 0 eigenvalue do not contribute to rank. Okay, so we are given that the rank of A we need to find, and clearly the matrix A is diagonalizable, so the rank will depend only on the non-zero eigenvalues. Okay, so non-zero eigenvalues are 1 and minus 2 and they are repeating so that their sum is 5. So clearly the rank of A is going to be 5 in this case. Please, this is crucial that A has to be diagonalizable. If A is not diagonalizable, then lambda equal to 0 eigenvalue will also contribute to rank. Okay, for example, if I take the matrix as a 0 1 0 0 type, okay, so clearly it has two eigenvalues, lambda is equal to 0 0, and you can see that it has a rank of 1. Okay, so lambda is equal to 0 eigenvalue is also contributing to rank. Okay, there is no non-zero eigenvalue, still it has a rank of 1. That's because this is a non-diagonalizable matrix. Okay, so the diagonalizable matrix condition is important here in this question. So clearly the rank of matrix A is 5, and the rank will depend only on these two non-zero eigenvalues. It will not depend on the 0 eigenvalue. Okay, so immediately we know from here that the rank of A plus 2i matrix will also be 5 because the two ranks are given equal. Now there is a property that if lambda is eigenvalue of A, then lambda plus C is eigenvalue of A plus Ci. Okay, so this is the property that if a lambda satisfies this equation, Ax is equal to lambda x, that means lambda is eigenvalue of A, then A plus Ci of x is lambda plus C of x. Okay, that means lambda plus C is eigenvalue of A plus Ci. Okay, so if we know the eigenvalues of A, we can immediately know the eigenvalues of A plus 2i. Okay, so what are the eigenvalues of A plus 2i? Let us say call it lambda 1. Okay, we are trying to calculate eigenvalues of A plus 2i matrix. Okay, so A plus 2i matrix will simply have eigenvalues by adding 2 to these numbers. So eigenvalues will be 0 plus 2, which is 2, 1 plus 2, which is 3, and minus 2 plus 2, which is 0, with the same algebraic multiplicity. So this has a algebraic multiplicity of 2, this has a algebraic multiplicity of alpha, and this will have a algebraic multiplicity of beta. Okay. Now importantly, the rank of A plus 2i is also 5, and so only these non-zero eigenvalues will contribute. So 2 plus alpha is 5, total is 7, so this beta has to be 2. Okay. And immediately you can calculate alpha also, that alpha has to be 3. Okay. This is because of a rank and diagonalizable. Okay, so 0 will not contribute to the rank, so clearly 2 plus alpha will become the rank, which is 5, so we can calculate alpha, and because total eigenvalues are 7, so we can calculate beta. Okay, so once we know alpha and beta, okay, then we will move to the actual question that we have to find the rank of A minus I. So again we can calculate the eigenvalues, in this case for the matrix A minus I. For this matrix, if I calculate the eigenvalues lambda 2, then clearly if I know the eigenvalues of A as lambda, then eigenvalues of A minus I will be, if I put C minus 1, will be lambda minus 1. Okay, so whatever are the eigenvalues of A, okay, which are these, if I subtract 1 from it, I will get the eigenvalues. So eigenvalues are minus 1, 0, and minus 3, with the algebraic multiplicity of 2, alpha which is 3, and beta which is 2. Okay, so that's the algebraic multiplicity. Okay. And again we will need to know the rank, and rank will depend on non-zero eigenvalues. So these two eigenvalues will give us the rank, and clearly we have repeating it 2 times and this repeating 2 times, so total value is 4. Okay. So lambda 2 equal to 0, eigenvalue will not contribute to rank, which is 3, and total matrix size is again 7 by 7. Okay, so clearly the answer for this problem is that rank of A minus I is 4. Okay, so this way you can easily solve the numerical. The whole process could have been easily done by looking at this value. Okay, because this was lambda 0 eigenvalue repeating 2 times, so obviously because of diagonalizable you can have easily written that this has a rank of 5, this also has a rank of 5, and then you can easily convert the eigenvalues 0, 1, and minus 2 into the, by adding minus 2 to this, adding 2 to this, so immediately you know the values of this, and then you can calculate rank of A minus I. Okay, so if you want to know more about this diagonalizable and eigenvalues and rank, then you can watch the lectures on linear algebra topic for more better understanding of this topic.